So up next, we have our own EVERETT TOEWS. He's on the Kareena team, been a long-time racker on effective Docker Swarm. Again, thanks for sticking with us, and you got it.
Thanks a lot, Jesse. OK. So we've heard a lot today about Docker Swarm and a lot about Kubernetes. And we were kind of approaching things at a pretty high level. And that actually works out really, really well for this particular presentation, because I kind of just touch on the high-level stuff, but I get a little more into the nuts and bolts of Docker Swarm and being effective with it. So again, my name is EVERETT TOEWS. I'm a developer advocate at Rackspace. And that's what I do. I jump off high things so my children laugh at me. So right now, we're going to talk about Kareena, our new containers as a service product by Rackspace. We're going to get started with Swarm. It's like super, super simple to do. So we're going to dive right in and get a deeper understanding and start using it a little more effectively. This is just like for your reference for later. This presentation is online. You can jump right into it, jump into any of these sections, but don't worry about that. So what is Docker Swarm? Well, if you've been around all afternoon, you've already heard about it a couple times from Ross and from Lee. But I'll cover it again for those who have just arrived, right? So like simply put, Swarm is Docker's answer to clustering. It's a way to bring multiple Docker hosts together and treat them as a single Docker host. If you've worked with Docker before, you might have worked at it in this kind of configuration on the left-hand side, where you had a bunch of independent Docker nodes just all together in your cloud or on your bare metal or where have you, living in virtual machines, and you had to treat each one of them independently, treat each one of them separately, and you care very much about which containers you're deploying to which node. And we actually have a number of applications running at Rackspace that are like this, running in that sort of configuration. But in the Swarm world, in the Docker Swarm world, it creates a cluster for us. It essentially wraps those Docker nodes and allows you to treat them as a single entity. It groups them together and allows you to treat them as a single entity. So what are some of the benefits? I'm not going to belabor this because we heard a lot about it from Ross and Lee, but I'll just quickly go through it. So kind of one of the primary benefits of Swarm is that it just uses the Docker API. It's the same API as the Docker engine itself. So in a sense, the difference is there is no difference. And that means that you can apply everything that you've already learned about Docker immediately to Swarm. So there's very little learning curve. If you already know Docker, you can jump to using Swarm immediately. And we'll get into the nature of working in a clustered environment a little later. So because it has the same API, you get to use all that ecosystem tooling that's already been built up around Docker. This is extremely valuable. There's tons of tools out there built for Docker and its API, and you can just go ahead and reuse all of that with Swarm. Naturally, what clustering does for you typically, one of the primary benefits, one of the primary advantages, is scheduling. And Ross and Lee dove into this in pretty good depth, so I won't go into it too deep. But there's a handful of strategies that Swarm ships with. There's the bin pack strategy, the spread strategy, the random strategy. Kareena itself uses the spread strategy, so we simply round robin containers to different nodes on your cluster as you run them. You can also use constraints to land your containers on a particular node. So let's say you have a container that has running a process that has like really intensive I/O requirements. It needs good I/O. So you want to land on a node that has an SSD on it for its storage. So if you have that node labeled with an SSD label, you can go ahead and specify a constraint, and your container will run on that node. Somewhat similarly is also the concept of filters. But this is more in terms of filtering so that you land on the same node as another container. So if you want to have an affinity with another container, you need to run these two containers together. You would use a filter affinity for that. Likewise, you can use anti-affinities to make sure that two containers don't run on the same node. And rescheduling containers. If you've got a node that goes down in your swarm, you need the containers that were running on it to be rescheduled to the other nodes in that cluster. This is something we haven't actually deployed yet, but we're looking at it very closely now that it's considered production ready in Swarm. And finally, this is something that was just released recently in Docker 1.11. You have on-cluster DNS. So each individual node has a local DNS server that you can use to resolve the names of containers. This becomes very useful, and I'll touch on it later in the presentation. And we're still kind of talking about pets versus cattle to some degree, because if you're in that world where you have a handful of independent, separate Docker nodes, and you're treating them individually, so yeah, your containers might be ephemeral, and you might not really care about them that much, but you still care about where they're going. You care about what pen they're in. You care about what kennel they're in, if you will. But in a cluster, you, again, really have to kind of get away from that mode of thinking, because you don't actually know where your container is going to be scheduled. It could go to any node on your cluster, so you can't bake in any sort of logic that depends on it being on one particular node. So we're getting to a point in infrastructure where the cluster is becoming the basic unit of compute. We had the server, we had the VM, and now we have clusters, and this is becoming the new normal. It's become the basic unit of compute. Where do I get a Swarm cluster? Well, naturally, of course, I think we already gave it away. The answer is Kareena is one place you can get a Swarm cluster. Put plainly, at this point in time, Kareena creates Docker Swarm clusters for you and hands them back to you. So it worries about all the machinations for bringing up a node, doing all the networking, and it simply hands back a Swarm cluster for you to build and deploy your applications on. And it is literally push button receive Swarm if you're working with it from our GUI, the Kareena GUI that you can use to actually create Swarm clusters. You push a button, you get a Swarm, 1 to 3 nodes, and then you can go ahead and download all the credentials and source files that you need to start utilizing that cluster. Some of the benefits of Kareena itself, the platform that we deploy Docker Swarm on, we have bare metal performance. There's no virtual machines involved in Kareena whatsoever, so you don't pay that hypervisor tax. You wind up with a 60% performance improvement from benchmarking that we've shown in a lot of cases, and it can be that much faster than virtual machines. It's extremely intuitive and easy to use. We spent a lot of time on the developer experience around Kareena, from the web interface to the command line interface and all the documentation. We've worked very hard to make it clear, easy to follow, similar to the Docker ecosystem of tooling, so that these things are already familiar to you within the greater container ecosystem. And you can literally get up and running in minutes, like from no account whatsoever to having a cluster running and deploying containers within 2 minutes. This is the kind of thing we speed time all the time, because we want people to get started and get started quickly and start Dockering right away, right? You can't Docker fast enough. And so we've got it down to about 2 minutes from nothing, from 0 to hero, basically. And should mention that Kareena is still in beta. We're looking to get out of beta by the end of the year and add a lot of great stuff as we go along, based on primarily user feedback and the use cases that we see when people are actually running their applications on Kareena. So speaking of getting up and running in minutes, these are a couple of links out to our Getting Started tutorials. If you'll notice in the bottom of every slide, there's a URL here, rack.to/swarm. I said I'm kind of a nuts and bolts guy. You can literally follow along with this presentation, from your laptop at your leisure and work through all of the command line stuff that I'm going to be showing you in just a minute. So these two tutorials here, you can either get started with Kareena from the GUI, or you can get started with it from the command line interface. So like the GUI is all well and good, but one of the primary advantages of these systems is being able to automate them. And that means scripting, and that means APIs. So we're going to start with scripting, and we're going to start with the CLI, and we're going to create a cluster with the Kareena command line interface. So we start with a call to our Kareena CLI, create a 3-node cluster, and we're naming it my cluster. A 3-node cluster takes about, a little less than 3 minutes to start up. A 1-node cluster, about 1 minute, naturally. So we've got our cluster, my cluster, up and running now, and we can start working with it once we source some environment variables into our terminal session. So we've got a command here, a subcommand of Kareena, env. This will probably look pretty familiar to you if you've used Docker Machine before, and this was very purposeful. We wanted it to be a similar experience to using Docker Machine. So we say Kareena env my cluster, and that tells you what you need to do to source the environment variables to work with your Swarm cluster into your terminal session. And conveniently, you can do an eval on this and get those environment variables into your session like that. So let's go ahead and do that. And we're going to grep for the Docker environment variables that we just sourced into our environment. So we can see that there's the Docker host. That's our endpoint. That's where we're communicating with our Swarm cluster. And TLS and certs, I'm going to touch on that a little later. And the Docker, the version of Docker that we're working with, the Docker that we're working with. And we're on 1.10.3 right now. I know that 1.11 was released like a couple weeks ago, and we're going to be deploying that sometime after the summit when we can put our heads down again and deploy it. And there's a lot of other things you can do with the Kareena command line, and of course you can just access those through the help. So this is the architecture for Kareena itself, for creating a Swarm cluster. So what we were doing there in the previous slide, and again, this is like the context here is running from my laptop. We're working from a laptop or desktop, what have you, using the Kareena CLI or the GUI, and we're going to create, read, update, delete clusters. So we're talking to the Kareena cloud to do that. Once we have our cluster, we're going to go ahead and use the Docker command line interface to communicate with our Swarm cluster. Now, there's like a lot of details in what it takes to run a Swarm cluster, but that's not what I particularly want to focus on for this session. I want to focus on actually developing, deploying your applications on a Swarm cluster. So if you want to talk Kareena architecture and how we actually run a Swarm, that's cool. Let's talk about that afterwards. And we've got some of the people here who actually built out the system on the product side of the team. There are a handful of constraints that you have to be aware of when you're using Swarm on Kareena. And the too long didn't read is that you don't have access to that underlying Docker node. Okay, so what is that? What are the implications of that constraint? You can't use volume mounts. You can't mount anything from the node. So for example, you couldn't use the -- volume flag and mount something from the node path to a container path. You'll get an error if you try to do that and access the underlying system that way. There is one exception to that, and that is if you want to mount the Docker socket. A lot of Docker ecosystem tooling depends on being able to access the local Docker socket. So we allow you to mount that socket and talk directly to the Docker engine on that node. And I'll get to a bit more about this in the data section on how you actually effectively get around this particular constraint. You can't use privileged or the capability add or drop flags. And there are also some app arm restrictions around what you can do inside a container. And these are all because of security. Kareena is a multi-tenant environment. And obviously, we can't have people breaking out of their containers and getting on to the node. And it's very, very safe and secure. One final thing, not so much a constraint, but there are a lot of swarm management containers that you get with your cluster. When your cluster is created, there's actually some containers already in that cluster that are actually running the cluster itself. This is how Swarm works. So you kind of got to take a little bit of care to not go ahead and blow those away, because you'll kind of cripple your cluster temporarily. But it's not the end of the world if you do, because you can just go ahead and use the GUI or the command line interface to go ahead and rebuild that cluster. So, like I was saying before, we used the Kareena command line interface to create a cluster. So that was the Kareena CLI. Now we're going to use the Docker CLI and start interacting with our Swarm cluster, right? We've gone from Kareena, now we're talking about Docker Swarm. So the first thing we're going to do is take a look at what we created with the Docker info. So when you get, this is the 3-node cluster that I just created. And as we can see, we've got 13 containers running on there already. Those are those management containers I was talking about. And you can kind of safely ignore them in the output as you will. So, and you'll see them in a Docker PS if you do a Docker PS-all though. And it's the Swarm management containers and some other containers for making sure that all the nodes are connected in the Swarm. Okay, so that's it for Kareena, in a sense. That's kind of where we in general stop talking about Kareena and we start talking about Swarm, right? So now we're going to get started on Swarm, run some containers, and deploy some applications on it. So, of course, you've got this amazing platform. What are you going to do? You're going to start a blog, because what else would you do? This is just a simple, non-trivial deployment, and I define non-trivial as anything more than one container. So we're going to use a couple containers, and we're going to deploy WordPress. And this is, very similar to the Getting Started guide that you can work through on your own. So we're going to start by creating a network for our containers. Then we're going to go ahead and we're going to run a MySQL container. And we're going to attach it to the network we just created, my network. And we're going to pass in a password for MySQL, our MySQL instance, get it up and running, all well and good. That's just fine. So now we go ahead and we run a WordPress instance, a container with a WordPress instance. We attach it to my network, and we're publishing port 80 this time because we want to expose this WordPress instance to the world so they can read our fascinating musings about anything, what have you, in whatever language you care to. Something I want to point out here is that we're also passing in this environment variable, WordPress DB host, and we're giving it the name of the MySQL container. So this is that DNS, that on-cluster DNS that I was talking about before, that resolves that container name to the IP address of that MySQL container, so we can connect to that database instance running on the default MySQL port. And again, we just use our DB password in there so we can actually access the database, of course. So that's up and running, and we're all happy. Now we can go ahead and start blogging in Esperanto or Deutsch or French or Francais or whatever dialect you're speaking. We can take a look at what we just created, the couple of containers that we just created. They're up and running happily. And now we want to see where we can actually access this WordPress instance running publicly so we can expose this thing to the world, because this is our front end. This is the bit that we want to expose. And we see that we have a public IPv4 address, and we already know that we're running on port 80. This last part is just a command if you're on a Mac that'll open up a browser and actually take you to your WordPress instance, and you can go ahead and let the world know what you're thinking. That's it. So we got started with Swarm. Literally, if you're just banging out that stuff on the command line, it can take less than a minute, and things get started very, very quickly. But once you move on beyond that kind of non-trivial application, when you start getting into running multiple services, you really kind of need to have a deeper understanding. And one is not simply effective, right? You got to think a bit deeper. You got to understand that you're on a cluster, and there are a handful of things that you need to do in order to utilize Swarm effectively. And it starts with something pretty basic, something that if you're familiar with Docker, that you've already encountered, Docker images. So let's go ahead and get into the nuts and bolts of using images on Swarm. We'll pull an image and run a container, something that you do all the time with Docker. So we pull Nginx, the base Nginx 1.9 image, because we always pin our images, right, to at least a minor version. And that pulls down that image to each node in the cluster. Okay? So now we've got that image on every node in our cluster. We go ahead and we run that image, much like we did with the WordPress image. And we're going to publish port 80 because that's what we want to do. We're running our Nginx and we're exposing it to the world. And we're going to do it again. We're going to run another one. We're going to run another Nginx container. We've run it again. And we're going to run it one more time. So now we've got 3 Nginx containers running using port 80. So we've used port 80 on the public IP address of each node in the cluster. So what happens when we try to run a 4th one? We get an error response saying that there's no node with port 80 left, right? That's what we expect. That's exactly what we expect. We ran out of port 80 on all of our public IPs. No more port 80. We expect an error. Makes sense. So let's do something that if you're actually developing your own custom image for your application that you're deploying with Docker, again, something very, very common, we'll build a custom image based on Nginx. So we'll create a directory for it. We'll get the Docker file for Nginx. And this is something that's pretty common. You take a Docker file, or maybe you go from some base image and you modify it a bit for your own environment or for your own requirements. Once we've done that and modified it for our own requirements, we'll go ahead and we'll build our own custom MyNginx image. And again, this just works just as we'd expect. It takes the context, sends it out to the node, and goes ahead and does the Docker image build as we expect. So now we're going to run a container based on that custom image. We go ahead, we run it. We take a look at PS latest. It's up and running just fine on port 80. It's exposed to the world exactly as we expect and exactly as we want. So like our previous example, let's go ahead and run another one. But this time we get a slightly different error message than we did before. It says, unable to find a node that satisfied image MyNginx. So it can't find a node that has our custom image on it. What happened there? I am asking you, what happened there? I know you know the answer because you've seen this already. Yeah, that's right. So the answer there was, it was built locally on one node, so the other nodes don't have it. Exactly. It was only built out to one node, and Swarm is intelligent enough that there's an implicit image affinity that when we said run for that custom image, it at least knew to schedule it to the one node that had that custom image. And so it ran happily that first time, but the other 2 nodes don't have that custom image, so it failed. So what can we do here? What's the solution? So this is another tutorial that actually gives you a handful of solutions, and hopefully this doesn't mess up too bad. But this takes you to some Kareena documentation that the Kareena documentation that Ross was talking about in the first tech talk here, and it walks you through the problem and the solution. And there's actually a handful of solutions to this particular problem. You can use a constraint. You can use affinity, like I talked about before. You can push that image to a public registry like Docker Hub, or you can use a private Docker registry on your cluster. That's a very popular option for people who are doing things in a production setting. Okay, so let's talk about data for a bit. We're going to create a volume and write some data. So I think this came out in like Docker 1.9 or so, the volume subcommand. So we can create a Docker volume, and we're going to give it this name, MyData. It creates it happily. We go ahead and we do a Docker volume ls, and it creates a volume called MyData on each one of our nodes. So we have this identically named volume on each one of our nodes. We go ahead and we write just a little bit of file data to one of those volumes, just a text file, and we're writing the word hello into it. We're doing a little hello world text file. So that's OK. That works as expected. No errors. Everything's happy, right? Now let's go ahead and read that little bit of file data back. Go ahead and read it. Runs just fine. We're saying, we're using this flag here to say, use this volume MyData and get the data from there. So we go ahead and we get it. We write it back, and it's happy. We cat it out. Again, we do it. Third time, didn't work. We got an error. What happened there? Anyone? Anyone? Bueller? OK, that's fine. So what happened there was that Docker volume created that identically named volume across all the nodes. And when we went to write that one little bit of data, it wrote it to one node, but not the other two nodes. So now we have this bit of data referenced by the volume MyData, just MyData, right? And if we run a container and it doesn't land on the node with that volume, with that data, we're going to get an error. So we actually just got lucky those first two times, and that we got to see the little bit of file data we wrote. So this particular one really kind of bugs the hell out of me. So here's a few different ways we can skin this cat. Not that I want you to go skinning cats. One of the ideal solutions is using a distributed file system underlying your entire cluster, so that whatever cluster you're on, whatever node you're on, whatever container you're in, you could mount something in from that distributed file system. That's not something we have today. That's not something that's possible today, but that's something that's on our roadmap and something that we're looking at implementing in Kareena for this reason. The real answer at the moment is using data volume containers. So this is a tried and true pattern in the Docker world, in the Docker ecosystem. If you've worked with Docker very much, you've probably used it already. If not, now is a good time to start. Naturally, you always want to back up and restore your container data. Again, these are links to tutorials that walk you through step by step how to do these things, how to be effective with Swarm. And I was so ticked off at this particular feature that I created an issue in upstream Swarm about it. The utility of actually creating a volume per node like this. And I've got a fair amount of traction for that issue, and I believe Docker is actually going to do something about it. So that was all file-based data. If you've got database data, if you want to write to a SQL database like MySQL or a NoSQL database like Mongo, you can go ahead and run your container. You can run your databases in your containers if that meets your requirements. I know some people are like violently against such a thing, think it's a terrible idea. My answer is always, it depends, right? It's what works for you, for your requirements, for your system. Or you can run it on something like Rackspace MySQL or Object Rocket Mongo if you want to have somewhere that's like a dedicated data store, highly available, amazing throughput, low latency to our data centers. That makes sense too if you want to pay for that data retention. Let's talk about networks a little bit and their use in Docker Swarm. We're going to go ahead and run Redis and write and then read a little bit of data. So we start a Redis container, much like we did our MySQL container, and we're publishing to the standard Redis port 6379, starting Redis 3.0. It runs happily. We check out where it's running publicly. We get our public IP address and the port that we specified back. Then we go ahead and write a little bit of data into that Redis database, that Redis key value store, and OK. we go ahead and we read it back. True, okay, it worked just fine, no errors. So that worked exactly as we expected. But that's awful, it's terrible. Anybody care to venture a guess why? Remember, the context here is my laptop, right? And I'm talking to this Redis instance out in the Kareena cloud. I just wrote some data to what could essentially be regarded as some random Redis instance, right? And read it back. Anybody else could have done that. This is a Redis instance that's running unsecured and exposed to the horrors of the internet and all the terrible things that are constantly scanning everything on the internet, which it's not difficult to see those things when you're running an average web server. So I'm kind of picking on Redis here, and I know that there's a way to run it slightly more securely by specifying a password. But in reality, Redis is very much meant to be run within a private network and not exposed to the internet at large, right? Going back to our creating a WordPress application, this time we're going to go ahead and we're going to run a MySQL instance like we did before, but notice I'm not creating a network first. Go ahead, we run that MySQL instance, we run our WordPress instance, they appear to run okay, but when I go ahead and I do I check out the logs from WordPress using Docker logs, check out the standard output from WordPress, I see that it can't find the database referenced by MySQL, right? And that's because there was no DNS resolution there. It didn't find the database using the container name MySQL. So the solution here is to just always use an overlay network. It's just the same simple solution, the most secure. It greatly reduces your attack surface for things like Redis. So just use an overlay network. You get DNS. You get to hide your stuff within that network, so you're only exposing the services that you want to expose. As soon as we got overlay networks, I added them to absolutely every single piece of documentation. Me and everyone else on the developer experience team went through every single tutorial we had, and we added overlay networks to everything because they're that important. Talking a bit about security, this goes back to that certificate bundle that we created and those environment variables that we sourced into our terminal session. So let's review those. TLS verify, yep, great. We want to use TLS good. And then we've got this Docker cert path, which specifies where we keep all of our certificate authority, the keys, the certs, and the Docker end file that sources it all into your environment. And living in that directory is actually a README file that you get when you download that cert bundle. And it tells you exactly what everything is, all of the different CA, the cert, the keys from the client and server, and how that's all locked down for authenticating and communicating with your Docker Swarm cluster. So good stuff. Some other solutions in this vein, jumping straight into it. Again, like I was saying before, use overlay networks so you're reducing your attack surface. We've got a great tutorial on patching security vulnerabilities with this tool known as Watchtower. What it does is watches all of the running containers on your cluster, and if a base image, let's say you're running some custom Nginx like I was before, if the base Nginx image gets updated with patches, probably security patches, Watchtower will notice that that base image got updated, roll your container so you get those security patches in your newly running container. There's kind of implicit idea that you're rolling your containers so often because you're doing CI/CD, you're doing continuous integration, continuous deployment so often that you're always picking up the latest security patches from the base images. The reality is that people are going to run containers long-lived. Some people are just going to run long-lived containers, and you can't stop them, but you want them to be secure. So you can use a tool like Watchtower to do so. This is another great tutorial using Nginx with Let's Encrypt for doing TLS for your websites, for your domains. This will get you an A+ rating with SSL Labs for your Nginx container, for your domain. Great tutorial. We've got a public key infrastructure tutorial. That's a work in progress. And we've also got this other issue about enabling a security sidecar in your clusters. So this is something, this is a call out for direct feedback from you, from people who are actually deploying applications on Docker Swarm, asking, is this something that you would find valuable? Is this like a value add that you would really appreciate? If you had like a button to click or a flag to pass in when you're creating a Kareena cluster, when you're creating, a Docker Swarm cluster, that it also included a security container like Claire or maybe Docker Bench that monitored your containers for patch vulnerabilities. So this is a link you can follow, and you can go ahead and comment on the issues. And the comments and thumbs up that we get on these issues, that is what drives the development, that is what drives the roadmap of Kareena. We take user feedback very seriously in all aspects. Talking a bit about service discovery. So this is like a really broad topic, and there's just a ton of different ways you can look at it. So I'm not going to get into like a particular problem about service discovery. It's just something you need to do to be effective with Swarm. So let's take a typical scenario where you've got a container that comes up, running your application server. Let's say you're running some Python application, some Django application or Flask application, what have you. And that needs to be registered. The existence of that container, of that service, needs to be registered within a registry. Once that is in that registry, you need something like a load balancer wants to discover that service to know, okay, I want to go ahead and load balance. So it goes ahead and does a service discovery portion, finds that is running and that it's interested in that service. This is the load balancer that's interested in this service. So it goes ahead and adds it to its load balancing servers and goes ahead and starts load balancing amongst those application servers. Coming back to DNS. So this is, again, a feature in Docker 1.11. Like I said, we're on Docker 1.10.3 right now, so we're looking forward to deploying that and being able to get this. This link actually links out to my personal blog. I had to get my hands on this as soon as it came out and just toy around with it and see how it worked. So you can use DNS, on-cluster DNS and Docker Swarm to do round-robin load balancing. So if you configure your Nginx or your HA proxy just so, every time you call out to a network alias, a DNS alias for your servers, it'll go ahead and return you a different IP every time in a round-robin fashion. So this is the kind of load balancing you can get just using basic DNS round-robin. There's another tool out there called Interlock. This was developed by a developer at Docker. It's not an official Docker project, but it's the kind of thing that you need every time you're going to run any sort of non-trivial application that requires load balancing. So its primary site is just on GitHub right now. It's repo on GitHub. When I came to the project, I immediately identified a couple of things that it needed, and that was that it has templates compiled into it. You might not necessarily want to use the templates that were compiled into it. You might want to use your own templates for Nginx or HA proxy configuration. So I've been working with this project and developing an upstream code to add that to it. Likewise, it also needs to work with multiple different services. If you're in this kind of microservice architecture, if you will, you need to be able to have multiple interlocks running on your cluster, each having their own configuration. So this is another feature that I'm adding to Interlock. And because I dove a bit deep on Interlock, I understand it pretty well. I'm not going to get into like a super detailed explanation of this, it simply notices that containers have been created from the Docker Swarm event stream, and then writes the address and port of that container to the Nginx or HA proxy configuration, and then kicks that load balancer so that it restarts and recognizes that it now has those additional application servers to load balance amongst. And I'm happy to dive deep with anyone on this after the presentation as well. So, there's DNS, it's like you're crawling. There's interlock, it's like you're walking. If you got to run, you're going to want the full service discovery stack. And that's, your etcd stack, using etcd as the distributed KV store, registrator for the service registry bridge, for that service registration portion, confd, a project from Kelsey Hightower for doing configuring, reloading, and Nginx or HA proxy for load balancing. And the reason that we didn't jump into this immediately is because, as you can see, there's a lot of complexity here. There's a lot of extra containers that you need to run. So if you're not familiar with Swarm or clustering, having users dive straight into this for their first taste of service discovery could honestly be pretty off-putting, whereas DNS or interlock are a little bit simpler conceptually to understand. And likewise, there's the console stack, similar, conceptually to etcd, in that you're using it for service registration, service discovery with these other tools. So what are some of the things that we've seen people actually building on Swarm running on Kareena? So I basically took all of the effective Docker Swarm tips from this presentation and encoded them in this tutorial. It's really pretty basic, but it shows off all the different things that I've walked through in this tutorial and creates a pretty simple Python Flask application. So this is how you would actually develop and deploy on a Docker Swarm cluster. I love this one. This is a blog post on the Kareena site from one of our ops people on the cloud DNS team. So they had a chat bot running on Heroku, and they brought it over to Kareena. And that movement, that shift, wasn't particularly challenging. The cool part about it was that they did it in less than an hour. From start to finish, less than an hour, done. And this is a really entertaining post that I highly recommend you check out. And Nick Silke, the guy who wrote it, was here before. You could probably flag him down if you wanted more details. This poorly taken iPhone shot is to demonstrate, running your kind of, if I have to say it, microservices architecture on a Swarm cluster. This is actually something that we're doing on the developer experience team. We run an application that manages all of our documentation for getkareena.com, developer.rackspace.com, and support.rackspace.com. And we're moving that from that independent, separate Docker node grouping, treating all of them separately. We're moving that over to Kareena, and that's a work in progress. So we're actually using that, we're dogfooding and using that to learn more about Swarm itself and how to use it effectively. This is a cool post on building a real-time game in Node.js on Kareena. Really cool, tic-tac-toe. If Fallout is more your thing, we also have a couple of posts on creating an interactive map on Fallout, based on Fallout, and we have the author of that post somewhere here too. This one is also, again, very cool. I know I'm kind of repeating myself and gushing, but I don't know, I just find this stuff really amazing. All of the great ideas that people are coming out with when they get their hands on this kind of tooling. So this is something called How to Whale, and it lets you create Kareena clusters on your own account in order to run Jupyter notebooks. So if you're not familiar, Jupyter notebooks are like this interactive web page that mix prose and being able to run actual commands within a web page. So you can go ahead and sign into this service. It'll ask for your Kareena credentials, and then it'll create a Jupyter server on your own Kareena cluster. And you're able to run these Jupyter notebooks. And the first one is, it teaches you how to use Docker. It's using Docker to teach you Docker to run more Docker, Docker, yada, yada, yada. I think we get it. But if you think a couple steps ahead, it doesn't have to be just about Docker. It can be about anything. If you have your own OSS project that you want to show off to people and let them interact with it in kind of like a executable interactive documentation way, this is a great project to show it off. You just Dockerize your project and make it available with a Jupyter notebook. Very cool. And of course, it can run your garden variety websites, pun intended. This is a website that's running in production on Kareena. And just wrapping things up, I want to say thank you very much for your time and attention here. This presentation is available right now at this link, rack.to/swarm. Like I'm saying, you can follow along with it at your leisure. This is going to be like an evolving presentation. So, you go to it today, it might not be the same a week from now or a month from now, because as I learn more about Swarm and using it effectively, I'm going to be updating this presentation and helping others use Swarm effectively too. And naturally, I encourage you to go to getkareena.com and check it out. My name is EVERETT TOEWS. Thank you very much.
All right. Do you want to take a few minutes for any questions? Or let me ask this. Anybody have any questions?
What does it take to deploy a Swarm, Docker Swarm? You've mentioned Kareena, which is sort of a hosted Swarm. What does it take to deploy your one? Suppose you have a bunch of nodes and you want to deploy your one Docker Swarm. Is it possible, first of all? And how difficult to do that?
So if I understand, the question is, how difficult is it to deploy Swarm on your own gear, your own nodes? Like you want to bring your own node. So, I mean, that's a great question for our back-end product team. The answer is always, it depends. It depends at what scale you want to do it, at what kind of, uptime you want to guarantee for it. But honestly, to kick the tires on Swarm, it's really pretty easy. Docker Machine does a good job of actually being able to create a Swarm relatively painlessly. I've got a script on one of my public repos that I call Swarmer, and it's just a script that creates a Docker Swarm in VirtualBox, using Docker Machine, because I want to be able to do development locally and then shift that up to Kareena. And that's actually what the develop and deploy Python application, that tutorial says. Okay, start with VirtualBox on your local machine and then shift it into Kareena. So Docker Machine makes it relatively easy to actually deploy a Swarm. Now, the caveat being, the networking in your environment may not play well with what Docker Machine, the defaults in Docker Machine, so it may require an awful lot of tweaking, and the devil's always in the details, I think is what I'm trying to say. And so your mileage is going to vary a bit in that respect.
Any other questions? All right, we'll release you, Everett.